Hello again, this is question 2 on the HL physics mock. And this question is about kinematics, so how stuff moves. It's a slightly complicated question where Lucy's standing on the edge of a cliff and throws a stone vertically upwards, and it's about how long it takes for the stone to reach the ground. The first part of the question, it gives you some information about the speed of the stone. Clearly says she's throwing it upwards, not downwards, and the height above the ground. And it also gives you the acceleration of free fall as 10, so that's nice and easy. The first part of the question is calculate the maximum height reached by the stone as measured from the point where it's thrown. So the equation we don't have any time information here, so the equation we're going to use is v squared equals u squared plus 2as. We know it starts off at a certain speed. Because at the top of this throw, it will stop. We know that the final speed, v, is going to be equal to 0. And we know 2 times acceleration, and we're looking for the maximum height there. So we need to rearrange in terms of s, which is the height, which in the mark scheme has been called h, and the acceleration, which we have here, is the acceleration due to gravity, so that's been put as g as free fall, which is 10. So that's our rearrangement of the equation. Plug in some numbers and you get 11 meters. Now, that's measured from the point where it's thrown, it's 11 meters. If you've added on the height of the cliff, then you'll get 91 or 91.25, and you'll lose a mark for that because it clearly says as measured from the point where it's thrown. So the answer should be 11 or 11.25. The second part of the question is to determine the time for the stone to reach the surface of the sea. Now this is additionally complicated because most people would determine the time it takes for the stone to get to the top using that information you just calculated, and then the time it takes to get to the bottom from the top, which is 2 calculations. Now, you don't have to do that. With the correct application of SUVAT, you can do it in one step, which is the example in the mark scheme. So if you worked it out separately, you'll get 1.5 seconds on the way up, and then time to fall 91 meters will be 4.3 seconds. You add them both together and you can get 5.8. Alternatively, you can use this application of the SUVAT. Now, to do it correctly, you just need to get your pluses and minuses in the right order. So the initial velocity was positive, or was upwards, which I'm going to call positive. The displacement is down 80 meters, and the acceleration is down 10 meters per second squared. Now, if you put those signs in, so positive, negative, negative, then we get this application here on the right. So minus 80 for the distance going down, plus 15 for the initial speed going up, and minus 10, half 10, for the acceleration. And either one of these, which is essentially the same sum, will give you a total time of 5.8. And that's the easiest way to do it. That's the most straightforward way to do it. And that's question 2.